Okay, this is stats. We're going to do our lesson, and I'm calling it right now for right now. I'm going to call it part one because I don't know how long it's actually going to take me, so I might have to stop and then do a part two if I run out over 15 minutes here. So we're going to start with chapter 1, which is exploring data, and then section 1.1 is what we're going to attempt today. And if you have your book at home, please just open it right next to you. It would be really great if you followed along in the book as we were going through this. Plus, you can always press pause, get things down from the book if it's not as clear in the video. And then also, you might want to have some graph paper with you just in case, you never know. And then if you need to press pause at any time, please feel free to do so. The PowerPoint is also attached to this assignment. So if you need to print, please print so that you can follow along. That way it makes things easier and it's easier for you to keep track of your notes this way. So 1.1, analyzing categorical data. So just remember, categorical data was something that would not make sense to take the average of. So things like hair color, brand of shoe, model of a car, things that we just don't have numerical values for that we can, where it doesn't make sense to take the average of those values. So we're going to, in this section, your learning objective should be to be able to display categorical data with a bar graph, which I think most of you have done before. It's just a little bit of a refresher. Identify what makes some graphs of categorical data deceptive, and we'll talk about a couple of pictures in the book that look pretty deceptive. And then after those two, if I run out of time in the second video, we're going to calculate and display the marginal distributions of categorical variable from a two-way table, and then calculate and display the conditional distributions of a categorical variable for a particular value of a categorical variable in a two-way table. And then lastly, we're going to describe the association between two categorical variables, and that is actually going to be the hardest out of all those. So let's see, the first thing is categorical variables. So if you'll remember, those were things that, it doesn't really make sense to take the average of, right? So in the categorical variables, in this case we have place individuals into one or several groups of categories. So in this case, we have the radio stations, right? Those are our individuals. Our category or our variable is going to be the format, right? Our variable in this case is going to be format of whatever that station is playing. So adult contemporary, news talk, oldies, rock, Spanish language, other formats, and then those are your counts. So how many of those stations are playing, or how many of those stations actually do have that type of a format. So 2066, radio stations. By the way, this is I think this one's in your book. I'm not sure, but I'll just double check. Yep, it's in your book. So I'm going to scoosh really quickly over to your book so you can see it just a little bit better. It's on page 8. So this many stations, right? We have, these are how many stations play that certain format. Now, and this is the percent of the stations. So when you look at it, you're like, well, that doesn't really add up to 100%, which is okay because we have a little bit of a rounding error. And the way that they figured these numbers out, okay, is they took, for example, we'll take adult contemporary, and I'll show you how they got 11.2. So let me take this out really quickly. So they got 11.2. We'll do the work really quickly if you're not familiar by just dividing. So 1,556 of these stations out of how many total? 13,838. Out of 13,838, if you take the top number divided by the bottom number, you should get 0.112 something something something. Okay, but since we're actually looking at the percent of the stations, so what percent out of all of your individuals actually played adult contemporary, it would just be 11.2%. They just didn't actually put the percent sign on there. All right. Now this all should add up to 100%, but because you have a little bit of a rounding error, if you were to actually take the division of 1196 over 13838 and so on and so forth, you probably do find that they rounded a little bit, a little too much. But 99.9% is pretty good. So that is the distribution. All right. Now from there. Okay, so this is your frequency table. Sorry, I forgot to mention that. And this is your relative frequency table. So frequency means how many. So how many times does something actually happen, right? The frequency of something occurring. Relative frequency is almost the same thing, except in this case, you're going to deal with the percents for this one. Okay. All right. Now, then the next one. It's sometimes, even this is the same one, sometimes it's easier to analyze a distribution by displaying it with a pie chart or a bar graph. So in one of them, we're going to show you the bar graph, and the other one, I'm going to show you the pie chart and what it looks like. Because it really is easier to see what's going on sometimes with those two. It may not be just as easy to see, with the frequency table or the relative frequency table. So this is what they look like. Okay, and this is your PowerPoint. I'm going to swoosh over to the book because it's in wonderful colors here. So you have a pie chart, which most of you are familiar with. Now, the problem with a pie chart is it's sometimes, especially in this case, it's kind of hard to see the difference between, okay, how much is religious format versus country format. I know it looks the same, but if I weren't really sure, it'd be kind of tricky to see. I know from the relative frequency that country is, let's see, if I scroll back over here, I know that country is 14.9. So it does help to know that. If somebody walked in and just kind of handed me this, it'd be a little difficult to figure out that that would be 14.9 if I didn't have the relative frequency table. But the pie chart, sufficient as it is, the bar graph is actually a little bit better. And like I said, you've done bar graphs before. So this is your bar graph. And this actually makes more sense now because I see that it's at somewhere less or somewhere around 15 because it's going to be somewhere in the middle between 14 and 16. And that makes a little bit easier to see what's going on or what the percentages are from the relative frequency table. And you should all be familiar with bar graphs by now. Okay, so those are those two. And then the next thing we got to talk about, good graphs and bad graphs. And I'm not going to spend too much time on this, but there are certain graphs that you've seen where they try to make it a little bit more on the biased side, meaning that they're trying to get something in on you. Okay, so from the PowerPoint, all right, we have bar graphs compare several quantities by comparing the heights of bars represented. Our eyes, however, react to the areas of the bars as well as to their height. So when you draw a bar graph, make the bars equally wide. You don't want to make, for example, let's go back to this one in a second. You don't want to make the green one up here like a fat. I'm going to say wider, but it's really fatter or wider than, the rest of them. Sometimes people will do that unsubconsciously because, they're just drawing something out. But it does actually change your perception of what's going on. Okay. And then it says it is tempting to replace the bars with pictures for greater eye appeal. Don't do that. There are two important lessons to keep in mind. Okay, so beware the pictograph, and I'm going to show you what a pictograph looks like in just a second, and watch the scaling. Okay, those two things are hugely important when it comes to bad versus good graphs. So here's what a pictograph looks like, and this is straight from your book. I'm on page 11. Okay, page 11. Here's a pictograph. Now, you can see right away that the way that this looks makes it seem as if You know, Macintosh is doing pretty well in this case. So in this problem, the question was, who buys iMacs, right? When Apple Inc. introduced the iMac, company wanted to know whether this new computer was expanding Apple's market share. Was the iMac mainly bought by previous Mac owners, or was it being purchased by first-time computer buyers or by previous PC users who were switching over? To find out, Apple hired a firm, and basically they summarized their results, and it looks like this pictograph. So just looking at it, you would say, oh, okay, a bunch of users are, you know, former Mac owners that are buying current Macs, which, okay, makes sense. But the way this one looks like, it makes it look as if everybody somehow, it's a huge amount, when in reality it's only somewhere between 300 and 400. I'm going to assume that they're going with the top of this thing. So somewhere around 350. So about 350 buyers were, you know, previous Mac owners. But the picture just looks much bigger than that, you know, and almost, well, I'm going to say like 80 were not previous Mac owner. We don't know what they are, and less than, or somewhere around 50 were probably Windows owners. But the pictograph is not an okay. Just stick with the bar graph, stick with some sort of a graph that you're familiar with. Next lesson, we're going to learn all about those. And then the other one, the other thing it said to be aware of was scales. Okay, so watch the scaling. Now, I'm going to show you what it looks like, even though you have it in the book. This is the scaling. When you're the one you're supposed to do correctly, obviously. You always start at 0, and then you have your increments. And if you're looking at this, it looks, okay, this is what it's supposed to look like. This is what it's not supposed to look like. You don't start your scaling at 10 to make previous PC owners look really tiny. All right, you want to know where your data is. And if somebody comes at you with a scaling that's off, you really have to ask yourself, why are they trying to do that? What type of bias are they trying to put in here? So this is bad. This is good. All right, don't scale starting at some random numbers. You really want to scale at 0. It makes things a little bit easier. Okay, so I'm at 12 minutes on this one. I'm going to stop because I'm going to get into two-way tables and marginal distributions and conditional distributions, and that might take just as much time. So I'm going to pause here. I'm going to not pause. I'm going to stop here. Just watch the next video.